Hi, my name is Buck Woody. Welcome to this session on artificial intelligence, machine learning, and deep learning. PASS isn't just the summit. Remember to explore everything it has to offer, from training and networking, local user groups, one-day local training events, marathons, virtual groups, and much more. Find more information at pass.org. Well, artificial intelligence, machine learning, and deep learning are intermingled terms sometimes. So we'll disambiguate those a little bit and explain what they mean, but they all follow underneath an umbrella called data science, and it is a real thing. You may have heard a lot of hype about it, but it's an actual thing. It's basically just applying scientific type principles and procedures to the process of collecting and analyzing data. It's really all it involves. So let's talk a little bit more about what's involved with it. The first part is the data analytics part. This is probably something you're quite familiar with. We have our standard create, read, update, and delete, our CRUD matrix. We have that. Learning about programming and controlling those programs is another part of the programmatic side of data science. Also reporting, still super important. People will ask me, is data science the next thing? It's another thing. Reporting is still very important and will never go away inside data analytics. You also have business intelligence, which is often historical data mining type tasks, or data mining type tasks being the predictive side of that. But business intelligence is usually historical in nature. Data mining, as I mentioned, is predictive in nature, and so on. In fact, data mining is sort of the forerunner to some of the machine learning that you'll see later in this session. But then there's also this storytelling. What do we mean by that? Well, when we talk about data, it doesn't just exist in a vacuum. It means something. When we're talking about patients in a hospital or dollars spent on the infrastructure of a building or something like that, there are stories involved with that. Making those stories compelling is part of data science. So if you think about this as being sort of the data side of data science, well, what's the scientific part, right? What's the science part that we think about? The first is the scientific process. And in the scientific process, there are four main parts. You probably learned this in school. Sort of define your question, create a hypothesis, test and document your results, and then you publish and you edit. You make sure you're peer reviewed. And a lot of these same things occur. Now, the create hypothesis isn't the same thing as I think all of these things are that, so let me go disprove the null hypothesis, that sort of thing. Although there is a bit of that inside data science, many times the hypothesis is, I believe this will predict in this way. And we'll see more of that as we go. But data science being the umbrella term as part of this. So now that we have that larger term, data science is sort of, if you think about a process and a procedure definition, now we get into the mechanics of what things are. Now, artificial intelligence has been around for a very long time. I'm a little older, and so I'm part of the age when we brought in what we call good old-fashioned AI, which were expert systems and other things. It's basically a methodology. It involves programming and things, but it's simply a methodology for using a non-human system to learn from experience. Now, that's the important part there, and we'll talk about learn from experience and what that means. And basically, it sort of emulates intelligent behavior. We want to be very, very careful here about how far that emulation really goes. We don't have commander data from Star Trek just yet, and we won't for quite a while, I think, although it can appear very, very close. Just like a picture can look just like the real thing, but it's not the real thing. It's a representation. Artificial intelligence is much like that. There's a couple of big camps. Now, I'm going to get a little fast and loose with some of these here for a little bit, but it's enough for us to understand what's going on. The first thing we need to think about is the symbolic processes that we use. And here we think about things like logical constructs, if A, then B, and so on. Expert systems were some of the earlier old-fashioned AI I told you about. And what this involves is basically taking someone and saying, how do you find out that this noise in the car means the carburetor is bad? Back when cars had carburetors. You could tell how old I am by some of these anomalies that I'll use, right? So the general idea here is that an expert system would say, well, I listen for the noise, and if it makes a click every 3 seconds, then it's probably the carburetor. And so I write down check noise 1 second, check noise 2 second, check noise 3 second. If true, then start to suspect the carburetor. And you basically build a fancy version of a bunch of if-then-else trees. And once you do that, you can mimic what an expert would do. And in large part, many things we do can be done this way. There's also simulations and fuzzy systems. Fuzzy systems mean, well, most of the time it's like this, but allow for things to be slightly higher or slightly lower in these values. It turns everything into math. Speaking of which, the next family we think about is the math side. And here we start getting into statistics, and this is what we do sort of today. We get into inferential statistics. We can infer something from a set of data that we currently have. We also need to think about linear algebra. That will come into play shortly. And then you get into two other theory buckets, information theory and decision theory. Now, there are more constructs within artificial intelligence, but these are the two large buckets that you'll see. While you don't often see symbolic anymore, there are vestiges of it that will show up inside our algorithms that we'll see here in a little bit. And I'll show you a very simple process of how this works. But before we go there, why create artificial intelligence? I don't recommend you do that. I actually recommend you don't create new artificial intelligence constructs. I think there are quite a few out there already that you can simply call within code. And in fact, I'll show you an example of that in just a few moments, how you can do this in your code today, even from inside a database system, to make a call out to pre-built AI. Now, what does this mean? This means someone has developed a model, which you'll see shortly about how those things are developed. But they've already developed the model, and when you're done training a model, and we'll explain what that means as well, when you're done training a model, all that's left is a kind of formula, really. And so you say, is this a dog? Is this a plane? Is this a cup? Is this a cat? And then the algorithm will come back, depending on what the algorithm does. There are image ones and sound ones and all kinds. And it will say, yes, that's a dog. No, that's not a dog. And I'm this sure. That's called a score or a prediction. And that's the way those work. But I recommend you don't build those. They've already been built. Quite a few have been built. In fact, let me show you a couple. In fact, more than a couple. Let me show you a few. These are the ones from Microsoft Azure, the Azure platform. They're called the Azure Cognitive Services. And they're basically a bunch of cloud services. And they have a REST or an HTTP type API. So you can simply build what you need by just stitching these together. And we have everything from the vision side, where you can have the computer recognize images, faces, ink recognizers, video recognizers, and so on, all the way out to language, speech, search, and decision. And you can see all of the different services are here. And in large part, everything you need to do is probably already done here. For instance, you have a database full of text and you want to recognize the form and fill out the text in the database from the form. You could simply upload the form, the picture of the form. It would recognize it and put everything in the proper places, and you would just catch the code and do the insert statements into your database that way. We have everything you can imagine, search, decision making, anomaly detection, everything you can think about. And then you'll notice down here on the right, there are these cognitive services containers. Now, these are containerized versions of the services that you see already pre-built. So you simply pull those down into a container, and you could include those, let's say, inside your Kubernetes environment or your container environment, and you could access them even though you're not directly connected to the cloud. Let's go see a quick example of this in use. Let's make this real. Hold on a moment while I switch over to some code. I've got a Jupyter notebook here that you can see inside Azure Data Studio, which if you haven't played with that tool, definitely go check that out. There are some sessions here during the past Summit conference where you can learn more about this tool. But basically, you connect to a server here and you can use all kinds of code, and one of those can be a Jupyter notebook. Now, a Jupyter notebook is nothing more than a set of HTML code, really, with two kinds of cells or locations. One is text and the other is actual code. And the code you run is based on the kernel you have available to you. I have kernels from Spark and Scala. I have Python 3, PowerShell, and SQL depending on which system you're hitting, it will have the kernel that you need, and you can run that. I'm actually hitting my local computer here to make this true. So here's the way this kind of works. Let's take a look at some pre-built AI. I'm going to use a text analysis, and what I'm looking to do is I'd like to basically get some analysis for text analytics, and we'll take a look at kind of how this works. You can see we can monitor our social media for issues. We're going to monitor worldwide. We're going to detect a language of a particular text that comes across. We're going to put that in a database, and then what we can do from there is we could get the sentiment from it as well. So we can make a couple of different calls. Well, here's what we're going to do. I'm using the Python language. And the first thing I'm going to do here is I'm just going to set up a few of the libraries I need. Now I'm going to use SQL ML utilities to set up an installation of the Azure AI Text Analytics. Now what am I doing here? I'm connecting to a SQL Server 2019 instance. In this case, it happens to be a big data cluster, and I'm going to use the pip program from Python to install a Python package called Azure AI Text Analytics. We have quite a few packages you can use for these pre-built AIs, vision, and so on. So I'm going to go ahead and pull that down. That's now installed, and the Python on my SQL Server can now use that library because it's been installed. So I'm showing the way to do it in SQL ML utils, and I'm showing the way to do it here in pip if you want to do it sort of that way. All right, both ways to install packages in Python inside SQL Server Machine Learning Services. Now, going out to the cognitive services on Azure, the Azure platform, all you have to do is just go out to Azure. I've got an entire section right up here that will explain how to create an Azure resource, how to get the key generated, and so on, and then how to formulate the request. We're going to do that in just a moment. But you'll go set yourself up an account, even a free one works, and then you'll get keys to allow you to make calls. That's all that is. Very simple to do, and you'll be given two things here. You'll be given a key, which is a long number. No, I'm not going to show you mine. And then you'll get an HTTPS endpoint for you to use the key to make the call, to send the data, to get the prediction, to do the work inside SQL. And here's all you have to do. Once you've set up those variables, now all I'm going to do is I'm just going to go get the text analytics client. That's from that library I brought in just a few moments ago. And then I also have the Azure core credentials to send up my Azure keys. I'm just going to assign those, as you can see here, and now I have the API all ready to go. So all I've done is set up a service in Azure. I've set up got my keys. I've put both of those as a variable, and now I've connected to Azure, and I'm ready to send those keys to that endpoint. Here we go. Now I'm going to create some documents. Now I could do these in various ways. I could do a language analysis to see if this is in English or Spanish or whatever. This documents would actually be replaced with a select statement or a Twitter feed or whatever that I want to predict. Now, obviously, for this one, we're going to put down your evaluation of this particular session, which is, this is clearly the best presentation I have ever attended in my life. And so now we have a variable called documents, and I think we're all ready to go. And this is all you have to do to get a function. All you have to do is say, I want to send something, and I want to bring it back. So again, you could have actually done a select statement, called out to the database and done a select statement here. We've just made up a document. That's what the brackets are. That's a group of documents. Could have been a bunch, by the way. We're going to go send those, and we're going to get our scores back, our predictions. And that's right here. Very simple. And by the way, I had this entire example documented for you within this notebook. And then all I do is just send it. That's as tough as it gets. There's no machine learning, there's no math, there's no science in here whatsoever. You're simply setting up the function you need to make the call. You make the call out to this Azure Cognitive Service. It's already pre-built, and it comes back with this. I think it's pretty positive. It's a 1.0. I don't think it's neutral, and I don't think it's negative. Those are the things we asked it for. And it says this is clearly the best presentation. Sentence 1 is positive. I'm positive that it's positive. 1.0. If it would have been like, I'm pretty sure this was a decent session, it might have gotten closer to 75 here and maybe a 25 here and a 0 here. And so I couldn't stand this session, then it may go to a 1 on the negative and zeros and everything. You see the general way this works. So now I could store that inside the database with the results from this query. And so I can do those over and over and over for any of the services you saw just a moment ago. So for artificial intelligence, I definitely recommend to buy, not build. Well, there is, of course, a lot more to learn. So we'll give you a link here for some further study. I've tried to make these short URLs as much as I can. This one's very easy to remember. We have a full school, aischool.microsoft.com, where you can go out and there are lessons upon lessons upon lessons. And in this school, you'll actually learn how to build these algorithms. But we're going to take a look at doing that in our next segment here on machine learning. Now, machine learning has a pretty straightforward definition. For instance, let's take a look here. A computer program is said to learn from experience E with respect to some class of tasks T and performance P if its performance at task T measured by P improves with experience E. That makes perfect sense, right? You completely get that, don't you? Well, I don't all the time. That gets a little much. So I tell you what, let's do. Let's take a graphical example of how this works. So you probably know what these are. At least I hope you know what those are. Those are cups. Well, 3 of them are cups, and 1 of them is not. Computers aren't very good with recognizing images. We are, but the computer isn't. So let's figure out how we can turn these into numbers. Now, how would you turn these not into numbers, but into words? So we could certainly tear apart the pixels and so on. That wouldn't really help us a whole lot more either. But how would you describe a cup? That's kind of interesting. And not only that, how would you describe a cup in a database? Well, let's take a look at how you might do that. First of all, we take the image and we tear it apart and we describe it in English. And first we say, does it have an open top? True or false? Does it have a closed bottom? True or false? Can it hold liquids? It probably has sides. True. And is it hand-sized? We don't want a bowl and we don't want a spoon. We want something hand-sized, and that's true. Then we'll say that is a cup. And basically that's what we're going for, isn't it? That's called the label. Now we view these just as columns and rows or as tuples or whatever you want to call them. But the general idea is here, we're going after the label and we're learning about how the computer is going to learn. These other attributes that we would call them attributes or columns, those are called features. So we know this information. This is called training data. We're going to show, by the way, this is how you learned what a cup was. Your mom said, cup, and you said, oh, okay. And then, she said, you held this up, and she said, is that a cup? And it's like, no, that's not a cup. That's a can. And you went, oh, okay. And you began to develop a mental model. Same thing here. So we see that the images, although they're slightly different, the first one's certainly a cup, second one's a cup, third one's a cup. Fourth one, though, that's my cat, Tina. And Tina does not have an open top. She does not have a closed bottom, guaranteed. Trust me, she does not hold liquid, and she is not hand-sized, at least anymore. She was when she was a kitten. Now she's fairly chunky, so she's not. So we guess that one's probably not a cup, right? Okay, so let's take a look now at really kind of making this true. We're going to go develop a model based on the data that we have here. So stick with me. Let me move out of the way for you here so you can see a little better what's going on. And let's now develop a model on how this is going to work. So here's our model. The model looks like this. If the open top is true, if the closed bottom is true, holds liquid is true, hand size true, that's our if. Then cup is probably true. Now we can't always make sure that the cup is true, but we're pretty certain that the cup is true. So now we're going to get rid of all of our data because we have the model. We've actually got the model for us that we're ready to look at. So let's now take a look here and see if we can use this on data that we've never seen. Let's take a look at some data we've never seen. There's your data. All right, let's apply the model. And when we apply the model to that data, keep in mind, I've gotten rid of all my training data. I don't need it anymore. So I say it's got an open top, it's got a closed bottom, it holds liquid, and it's hand-sized. I'm going to guess it's true, but it's facing a different way. It's blue. I think that's hand-sized. I'm going to guess it's probably true. That's the way machine learning actually works when we're developing or learning our algorithm. Now, this is called training a model. Now, keep in mind, let me move myself back out of the way here. Here we are. I'll move myself out. When we're looking at this data table here, I've got to figure out which is my left and right. When we look at this data table here, the general idea is that we don't actually have this few. We have like tens and tens and tens of thousands of examples, and there are many, many, many more attributes and so on. So what we do is we have the computer run over that with various math algorithms, and it tries to fit an algorithm to the data that it's shown. And then what we do is we hold out part of that data, and we still know the answer, but the computer doesn't. We then run a test to see, okay, what do you think? How about number 2 there? Is that a cup? How about number 3 there? Is that a cup? How about number 4? And so on. And then we score those to see how well the model performs. And that's how the performance of a model works. And so then once we've tested it and we like that performance, then we save the model that's just right behind my head here. And that's how that sort of works. Okay, so that's how machine learning works. I think next what we should do, we should go see an example of how this really works. All right, I mentioned at the very beginning that this is machine learning and AI and DL for the deep learning is all part of data science. And data science is not just the tools, but it's also a process. And so there's a full process you can find there at aka.ms/TDSP. That stands for Team Data Science Process. And what you do is you go through various phases inside these things to make it a full scientific process. I'll let you hit that link and learn more after you've watched this particular session. So in the first phase of the TDSP, we try to understand the problem we're trying to solve. So what we're trying to solve here is the Orange Telecom company in France is trying to figure out, will someone churn or not? What does churn mean? Churn means you currently use our service, but you don't want to later. You're going to leave. You're going to go to a competitor. You're not going to use this at all. And there are various reasons. And it turns out it's very expensive to get a new customer, but it's not that hard to keep old customers. So you need to focus on your older customers so that you don't lose them while you're still trying to gain new customers. So you can take a look at customer records you have, find out if any of them have left, and see if there's anything that got close at the beginning to why they would change. Why would they churn? Did they have bad customer service? Was the price too high? Was it both of those things? We can use machine learning for that. So the first thing I'm going to do during my setup is just going to frame my question. So I want to say, will this person churn or not? So I'm going to look at people who have churned, and I'm going to keep some of that data away, and then I'm going to walk through this. All right, first thing I'm going to do is I'm going to grab I'm using Python again. You can use R, Python, Scala. Lots of languages can do machine learning. We're going to stick with Python throughout this video. So I'm going to import a few libraries here. It doesn't really matter at this point what these are, but the one that you want to care about a lot is the Scikit-Learn, it's called. And this has a lot of the math models that we need. And we're going to talk about the models and what they do shortly. We're also going to talk about the fact that we're creating an experiment. We're going to try a couple of math models to see which one works best. No, you don't try them all. I'll show you in a moment where they sort of fit. But in this family, these two, a decision tree and a standard Gaussian distribution, will help us understand what we're looking to do. That's where you kind of need the stats and the math background for this. Okay, so we bring these things in. Pickle is a library that lets us store the results so we could make a persisted model of this later to do the scoring. Pandas is a data library. NumPy is a numeric library. And CSV works with comma-separated value files. So we've got all of our libraries ready to go. Now we move to phase 2, which is reading and understanding our data. So the first thing we'll do is we'll read data. Now notice I'm actually reading it from a blob out on Azure, but you could actually read this data in from a SQL Server, from Oracle, from Python files somewhere else. Doesn't matter. You're streaming some data in. These happen to be our records, but I need to look at them. So I'm going to print their shape, which is a lot like just doing a select of a schema. and I'm going to take a look at the size of the data. I could look at the last 10 rows, the first 10 rows. I have those commented out, and then I'm going to take a look at the structure, and this is how we're going to look at what the data looks like. And I've got missing values and statistical, and I've got those commented out just for our time's sake today. So you can see here's what we know about our customers from the data that we've pulled in off the web. We know their age, annual income, state, total minutes used in their last month, all kinds of things. These are our attributes. These are our features, and this is what we want to know. So we also want to find out now, did they churn or not? So our label is right here, the churn. Did they churn or not? Now what we're going to do is do a little data modeling here, and we need to clean up our data a bit. The first thing we're going to do is we're going to get rid of some null values. That's NA inside Python. You want to be careful here. Your statistician needs to help you decide, do I put a value in there? Do I remove them? Do I add an average value? Do I add a wandering average value? There's lots of ways to do this, so you want to get with them. And I'm going to drop the duplicates. Once again, you're going to make sure that your statistician is involved, your data scientist is involved to make sure you can do that. Then I'm going to get rid of years and month and so on. Now, this is something that's kind of interesting. I'm going to implement something called Hot Encoding. What in the world? What this does is it takes words like red, green, blue inside of a field, and it's almost like a pivot table. It'll make a red column, a green column, and a blue column, and put a 0 in each one that isn't true and a 1 in the ones that are true. So if it's red, it won't say red. It'll say red 1, blue 0, green 0, and so on. So I'm doing that because when you're dealing with statistics, you need numbers, not words, different kinds of things. And there's a whole link in here that you'll get that shows how to do that. Okay, I will then rejoin everything and put it all back together, and now I'm finally ready to do my modeling. I'm going to take all my data, and I'm going to take my Gaussian model, that's the one that we put in from Scikit-Learn, and I'm going to randomize it, and I'm going to keep out 30% that I'm not going to show the model. I'm going to test and see how well the model does when it does its predictions, but I already know the answers from the data I'm providing. So I'm going to give it 70% to learn on, 30% to test on. It's pretty common to do that. You don't want too much on either side. And then all I do is just say, hey, you know what? Train test. Use the data frame, get the random state, get the test size, and get the split ratio. Everything's here. Just go do it. And it creates that and shows me what it needs to be. Then what I'm going to do is print out how well the naive Bayes does. And then I'll experiment using decision trees. And it's very similar. I'll create a model, and it uses the min samples, and this one's going to split 20%, and there's a reason for that. And there's going to be a random state, which is another variable it needs to do that. Okay, so we have all these things. Then I'm going to print out the predicted. So it wanders through all the data, and it tells me that naive Bayes is about 90% right most of the time. It's a long discussion about how it came about to get that number, but it's about 90%, which is actually a bit too good, but that's fine. We'll go with it for now. You don't want your models to be too good because they might be doing something called overfitting. All right, now we move to the decision tree, and we see that it does slightly better, about 91% accuracy. Now what we can do is we can pick the one we like. We happen to like the decision tree model, and we're just going to persist that out. And then what we can do is we can load that pickle in another location. This could be out on Edge or on any kind of device that can do these things, even a Flask application on the web. And we set up a little fake call into this service. So this is all we had to do was that model pickle. That's what happened above. We turned that model we created into a model pickle file. We have it sitting there waiting. There it sits. It's just waiting. And now we send it a document. We actually send it some fake data. We say, here's this person. His name is Buck. Do you think he'll churn or not? It will come back and it will say, I don't think Buck is going to churn. And it also saves out the location of the pickle file for me. So now you've seen the way you can build AI. We saw how you could use AI, and now we've seen the machine learning and how you build and how the machine learns from data. It's all math. It has to figure out the parameters, and it goes from there. Okay, now we've seen artificial intelligence. We've seen machine learning. And we need to finish off on this topic because I really only showed you a couple of algorithms. But algorithms actually live inside families, and they're well suited to the data that they work with. And it also depends on what you're trying to predict. So let's take a look at some of these. Now, the first thing you need to understand is that the data will either have labels or it won't. Sometimes we don't know the answer of what we're looking for. We literally don't know. We just want to group something or that kind of thing. We'll talk about those in a moment. Most of the time we have labeled data. What does that mean? It means we know the answer. You remember we were looking at the customers that have churned. We were looking for data that we did know was a cup and so on. So we have the the attributes that are going to predict the features, and we have the attributes that are being predicted, which is the labels. There'll be a label. So there's a couple of ways you can think about this. The first is that there are four basic supervised, and this means the data is labeled, and if it's got the label in it, that's called supervised learning. And there's four big groups of these algorithms. So there'll be lots of algorithms inside each of these groups. I'm going to give you a resource in a minute that will show you a cheat sheet of when to use each one. But let's assume you're trying to figure out a category. And there are two kinds of categories, multi-categories and single categories. Single categories are churn, not churn, cup, not cup, and so on. Now, you might have multi-class, meaning it is either a cup or a plate or a fork or a knife or whatever when you're sending the data in. In essence, those multi-class, by the way, are really just lots of single tests, but they're optimized in a certain way. These are called classification algorithms, and there's a family of them. You saw a couple of them just a moment ago, the naive Bayes, and you also saw the decision tree and so on. There's also a regression algorithm, and a regression answers the question, how much or how many of these things will happen? One, more than one, 50, and so on. So regression you can think of as a line. You learn slope and intercept and all that kinds of things. There's actually regression algorithms inside. And then also anomaly detection. And an anomaly detection says, is this odd? Now, that all depends on what odd means. If I've got a group of things and they have a normal state, then I can look for the oddities within it, and you can train algorithms to say, that looks a little outside the range of what I care about. And then finally, we have our reinforcement algorithms. And these reinforcement algorithms will say, here's what you do. So if you've got like one of those automatic vacuum cleaners in your home, the little circle one that bumps into the walls, those actually don't just bump into the walls. They actually have a little computer on board, and they're tracking when they got close to the wall, and they know not to do that again. And they do that with a reinforcement algorithm. It's kind of interesting that even our vacuum cleaners now have artificial intelligence within them. And there's a group of families that have these. And again, inside the notes view of your deck here, I've got these listed out for you. Then we have our unsupervised. So now we've just got a bunch of data. And there's two that you'll see quite often. And again, there are more of these. These are just big families. The first is called a clustering algorithm. And what a clustering algorithm does is you just kind of throw down a bunch of data on the floor and say, okay, start arranging that. And I could say, get them into piles of six different piles. And what you would say is, well, this one's the same size as this one, so I'll put it together. And after a while, you're like, well, I got 8 piles. So even though it's the same size, it is a different color. So let me combine these 2 piles, and I'll do it by color and size. And okay, now I've got you 6. So you can get the general idea of how that works. Maybe you want to get it down to 3 piles or 10 piles or 100 piles. Where would you do this? Well, you might do it with your customers to see who your high spenders are, or who people will go to be influenced by, or who will buy shoes on Thursdays, and so on. Depends on how many piles of things you want for your clustering. But it doesn't need to be supervised. You don't have to tell it ahead of time what you're looking for. You simply throw the data down and say, you figure it out, and it will do that. Next is a recommender, and you've probably seen this before. If you've ever gone out to a site where it says people who buy this book like this book, and people who buy this product like that product, they're doing that with a recommender algorithm. So these are the algorithm families that you can use. Someone once asked me, why don't you just try all the algorithms and see if it works? Well, that's not really the way it works, although there is a new paradigm where it actually can try the right algorithm families based on the data you're showing it and what you want to do, sort of an auto ML kind of construct. Microsoft has this, as do other companies. So there's that. Now there are various languages and libraries you can use to do machine learning. It's not just Python and so on. So let's take a look at a few of these and see which one of these we can go with. And again, you're not limited to sort of a single language. You can use lots of different languages here. So let's take a look. First of all, there's R, and believe it or not, R's one of the most popular data languages there is. So definitely take a look at this. Lots of data science work and lots of machine learning can be done inside R with these libraries that you can add into it. Python is back and forth with R, taking over as to who's the most popular. You can't go wrong learning either of these packages or programs. The one we just used was Scikit-Learn. One that's very popular is Tensorflow, and one like Tensorflow is called PyTorch. Let me explain the difference between those two. Tensorflow was put out by Google. PyTorch was put out by Facebook and a consortium. And you'll often see, or at least what I'm seeing currently as of the time of this recording, is that TensorFlow is used primarily in commercial enterprises, and PyTorch is used quite a bit in the scientific and sort of education community. So you'll see that a great deal. Some of these things are based on each other, like NumPy forms the base of many of these things. So those are the things you can use. There are platform-specific languages you can use, or programs you can use, Spark, Hadoop, and so on. Inside these, they'll have their own. For instance, Spark has PySpark, SparkR, and SparkML. So you'll see that used quite often as well. Let me get myself out of the way here. Here we go. Zip over there. It's nice to be able to do that. I wish I could move that fast in real life. Java isn't used as often in machine learning. It can be used, and if you're a Java aficionado, my apologies, but I don't see it used quite as often inside data science or rather AI. Now it does some really cool things, especially for n-grams and so on, that it does well, but I don't see Java used a great deal. Now SQL shouldn't be included here at all, with one exception. Inside SQL Server 2019 Machine Learning Services, we have increased the predict statement in Transact SQL to be able to use models that have already been developed in machine learning, so you can predict certain things. If there's a list of the models that are used, you can predict in Transact SQL with a Transact SQL language. So it now qualifies as an AI language, which is a bit odd. Now you can also, with machine learning services, run Python, R, and Java inside SQL as well, but this is literally another statement that you'll see. I do another session here at the summit that talks about all your options that you have available, and you'll see those available here in a bit as well. Okay, well, let's get some further study for this, and you can see here there's a bit of a link that you can follow here for more on how to do this yourself. Prepare to be embarked upon a very interesting world. It's fascinating stuff, and there is math, so you're going to have to deal with the fact that you're going to be jumping into some math again as you move forward. Well, now let's take a look at the deepest part of our study, pun intended, deep learning. So we've looked at artificial intelligence and how it's part of data science, and then we took a look at how you make artificial intelligence with machine learning. Now we're going to dive off into some other constructs and maths that we need to understand in a field called deep learning. Now, deep learning involves layers, and we'll be showing some of these and some of the math. At the very end, I'm going to send you to a video after the demo that we go through here. I'm going to send you to a video. It's about 3 hours long, but it's very well done. And in this 3-hour demo, this teacher, who's quite good, goes over how deep learning works. And even there, it's simplified. So this is complicated. But even though it's complicated, it's trying to simulate how the neural pathways in your brain works. But it is nowhere close to how the brain really works. Your brain is amazing. You may not always think that to be true, but it is. Your brain is amazing and can do amazing things. So you'll want to watch that video when you're done to go much further in this. But let me give you some broad strokes here. Now keep in mind, whenever we do that, we lose some fidelity. So when I show people and teach deep learning, at least at this high level like this, I'll often get people write me back, well, oh, you missed out on these things. Of course I have, because we've got a very short period of time. Hopefully it'll all be correct, but it may not always be complete. So what is deep learning? Well, it's layering various algorithms to simulate what a neural network does. Probably works best with a picture. So last year, I had the privilege of going to South Africa. And then when I was in South Africa, specifically in Johannesburg, they took me out to where the animals are. They often joke that the humans are in the zoo in South Africa, that the zoo is actually the whole country and you're the attraction. So we're in the car and we're driving along and we're seeing different animals. Look, there's a cheetah, or rather a hyena. Here's a lion, and all these kinds of things, fascinating things. And you see a lion up close, you're like, oh my gosh, how big that is. And then they said, and here are the wild dogs. And I said, where are the wild dogs? They're like, they're right there. You see them? And I'm like, no. And quite literally 4 feet from, I don't know what that is in centimeters, I'm sorry, or millimeters or whatever that is. I'm not from Europe. Well, I lived in Europe, but I still didn't learn the metric because I'm an American. Anyway, 4 feet from the car, not very far, about a meter from the car. He pointed and said, no, look closer. And right there was the wild dog. I mean, it's right there. But in fact, there are 14. In the picture on the left, there are 14 wild dogs. Once I saw them and saw how to look, I started counting. I'm like, oh my gosh. And he's like, yeah, that's nature, and they're camouflaged really well. And you could probably start to sort of see them. Let me see if I can get my mouse. You can start to sort of see some of the dogs here, right? As you start piecing them out, you're like, oh my gosh, there's another one, there's another one. And so you start seeing the dogs. Well, this is a problem that machine learning would just absolutely fall down on. There's just no way to create a good model that would do that. But this is within the realm, although it would still be very difficult to do within a deep learning network. So let's take a look at the parts of a deep learning construct here. The first thing you need to understand is there are various layers, and I've only got 3 here because there are 3 types of layers that you'll see in most networks. Now, there are lots of kinds of neural networks, and we're just going to talk about an artificial neural network, or an AN. There are GANs, and there are convoluted GANs, and there are all these other kinds of convolutional GANs. There are all kinds of deep learning constructs here, so I'm going to very simplify this. All right. What you have on the front end is some numbers that come in as an input, is the way this works. And that goes into something called the input layer. From there, if it's a fully connected layer or graph, and this one is an acyclic graph, meaning it doesn't cycle back around on top of itself, it's just going one direction, you'll see that as that input comes in, it hits something and says, okay, you're a number, or whatever it happens to be that comes in. And it goes from there into some hidden layers. We've only got one here, a hidden layer that does some more math, and then that gets triggered, and finally there's an output layer and it gets a number. Now that may seem a little confusing here, so we're going to work through an example together, a very simplistic example on how this works. And again, the simplicity can be wrong, but it's enough to illustrate what we're doing. In fact, these are more complicated than it looks. Here's one of those little round things there. There's a formula inside, and you can see that the inputs that come in on the left there come to this function, and the input even gets a weight. So if you think about it, your eyes work this way. Light comes into your eyes, and it's got various components. It's got intensity and brightness, and there are various forms of color that come in, and you've got rods and cones in your eyes that take those photons that hit your eyes, and they turn it into a kind of thing that your optic nerve understands, and it's actually upside down when you're looking, and your brain then takes that and turns turns it right side up and begins to tear it apart. Here, let's take a look at an example of one of these. Here's a more robust layer, and you can, or network, so you can kind of see how this works. So the input layer is a face. That gets turned into numbers, and those numbers then with these fuzzy parameters come around, and one layer may do edges and the next does combinations of edges, and then maybe types of those combinations like eyes and teeth and mouth and hair and so on. And at the very end it compares it to some models that it already has and says, ah, this is a face, this is that face, this is a dog, there's the dogs in the grass, and so on. So that's the way these things work out. Now, again, much more complicated than we're sort of seeing here. So complicated, in fact, I think an example probably makes sense here, so I've moved myself out of the way a little bit, and we're back in our Jupyter notebook here to take a look. So again, I want to make sure you understand this is a very simplistic version of this, but it'll get us an introduction to what's happening. So let me just wander through this step by step, and let me tell you what we're trying to do. There's a very famous use case of the United States Postal Service that wants to pull apart the handwritten letters. We used to send letters back in the day. They went in paper envelopes, and you would write down your address at the top, and then you'd write down your friend's address in the middle, and you would send emails, or rather mails. Now we've replaced those with emails, but at any rate, you would send a mail, and it would have to figure out kind of how to get there. So the person's name was at the top, the next one was the street, house number, street, and then below that was the city, and then the state in the US, and then we have zip codes in the United States, which are numerics. So something had to like look at that and go, ah, yes, okay, Los Angeles, California, that goes to the California post office, that goes to the Los Angeles post office, that goes to the post office nearest your street, and then that goes to your house. And it kind of figures out how to get there in that way. But a person did it. So they said, hey, back a long time ago, they said, could we invent something to where a camera could begin to recognize the handwriting? Now, if you have perfect handwriting, it would be pretty simple to do just with machine learning. You just like, show it some number and say, that's an L, that's an L, that's an L. Oh, okay, I'll guess that. But as you know, nobody's handwriting is the same. I learned cursive handwriting. I'm not sure how many people still use that, but handwriting can be different. An L can lean this way or that way or straight up and so on. So it looks all different. So that's the use case we're trying to do. We want to read envelopes. If you're looking for some more documentation on this, I've got a bunch in the notebooks here and in your slide deck. And this is called MNIST, M-N-I-S-T. Doesn't matter. That's the letter set that was used to do this training. All right, let's get our Python going here. And the first thing we're going to do is we're going to get the NumPy numeric Python library. And we're going to go get a sigmoid. Now, what in the world is a sigmoid? Do you remember that little function I showed a moment ago with a little formula there? There's a point at which something gets tripped or not. So it's not just zeros and ones. Things are levels of zeros and levels of ones to get tripped. And so you need to define a function that says, if it's above this threshold, do it. If it's below it, drop it. It's not important. And so this sigmoid smooths out and tries to figure out the closest right answer. Again, everything is still a guess. All right, so I'm just going to define a sigmoid. Don't worry about the math right now and the derivatives. If you don't remember those, it's more than we can cover right here. And the next thing we're going to do after I've just defined a sigmoid, it's all I've done, and a derivative, that's all I've done, and I brought in numerics to be able to do that. That's how it gets the NP right here. That's the NumPy. And then I just go get the thing to define the sigmoid and the derivative of the sigmoid, and we go from there. Now what I want to do is create a neural network class. Now this diagram you see right here is simply the same diagram I had before, but it was sideways and now it's up and down. So this is why it's called deep learning, because there are many, many, many hidden layers. All right, here we go. So we're going to set up our class in Python. So I define a class called neural network, and I'll be adding to that as we go through this. Do you remember I said there are these weights that come in when your colors come into your eye, and they have a little function on them that set how that's being interpreted? For instance, if you look outside during the day, you see the light and a car coming at you in a certain way and you recognize it's a car. When it becomes darker in the evening, but it's still light out, you can still tell it's a car, even though it doesn't exactly have exactly the same lighting on it. So you might say that's weighted in a little bit. That's a terrible analogy, but there it is. So I've given it some weights. Don't worry about those at the moment. If you're really interested in those, go watch the video. I'll show you in just a moment. So I've created my initial neural network class. That's all I've done. I've just defined some things to get ready for my neural network class. That's all I've done. Now I need to do some things that's going to do multiple parts to this class. So the first thing I'm going to do is I'm going to add feed forward. Do you remember I said that we've got these inputs here that are sending to the hidden layers? This feed forward, we're just going to 2 layers is all we're going to have, just 2 of those hidden layers there inside. And all I'm going to do is move the input of one layer of the nodes onto the output. That's all I'll need, and move it through. So I'm gonna evaluate the shapes and send along with the weights that we want to set up to the next level. So again, don't panic over this just yet. I'm just building my neural network. So I'm just taking care of my neural network, and I'm just kind of giving it some feed forward here. And don't worry about bias, and don't worry about anything else. I'm just going to give it some layers. I'm going to use my sigmoid function to send on to the next function. So all I'm doing is taking my sigmoid, and I'm just simply taking the weights, adding them, and that's the trigger that it'll move on to the next neuron in my neural network. Okay. And don't worry about the bias right now. Again, the instructor covers that in more depth if you're interested. It's just math is the way that goes. Now, the really tough parts of the math, and I'm just going to really glaze over this, and I'm sorry. A loss function is very important. And basically, as this thing's being evaluated, as it's doing its training, it's trying to minimize how poorly it's doing. I know that's a weird way to say it, but that's what it's trying to do. It's trying to optimize. And it's called a loss function. And basically what that will do is try to get as unwrong as it can. Is probably the way to do that, is just get as unwrong as it can. And it can use that in a fast way there to get the prediction to do something called gradient descent. And if you saw this, it would look like one of those parabolas with the grids that you see in a little ball that tries to find the lowest area. That's what that does. And to get all of that together, we use something called a chain rule. And that's where our derivatives come in. And it chains the computation. And if you really want to know more about the chain rule, I've got a video that helps you understand how to do that. All that being said, I've got my feed forward, I've got my class from my neural network, my feed forward, and my back propagation. Oh my gosh, quite a bit going on there, but it's okay. It's just math. We're just trying to move things from one neuron to the other and try to be as unwrong as possible, as correct as possible. Okay, now with all that being set up, I now have sort of a function I can use. And here's a 0, here's a 0, here's a 0, here's a 1, here's a 1, here's a 1. You can see some of these are wildly different. Look at the 5s. Some of those really look different than the other. And the 4s, really? That's a 4? Yeah, it is. All right. So what we're going to do is we're going to cut out each of those letters. We're going to take a picture. We're going to cut out just that picture. We're going to draw a grid. We can do that with math, right? Find the empty area, draw a grid around it. And then what we're going to do is we're going to make it into a grid. We're going to just lay a grid over the top of it like this. And then we're going to say that dot in there is like a pixel, if you will. And in that pixel is either lit up or it isn't. I think you can kind of follow what I'm doing here. If I had this 0 and I put a little grid over it, maybe this first thing would have no pixel, no pixel, pixel, no pixel, no pixel, no pixel, pixel, no pixel, pixel, no pixel. You get the idea. We're just drawing a little box. All right, here we go. I'm going to go for L's. This is numbers. I'm going to go for the letter L. So I've grabbed a bunch of these, and I've got some images here. So I've just got them cut out. First of all, these were the things around the L's, right? Or not L's too, they're both in here. And then what I'm going to do is I'm going to lay a grid on top of them. So this is exactly this, this is exactly this, this is exactly this. But this lets me now do math on them, right? Nothing, 1, nothing. Nothing, 1, 1. nothing, nothing, nothing. Make sense? So to do that in sort of an array, or what you might call, I don't know, a tensor, this is where our TensorFlow comes into place, we just unroll these. Let me show you what I'm doing here. All right, here they are. So this one is 1, 2, 3. That's 1, 2, 3. Okay? 1, 2, 2. 1, 2, 2. You with me? And 1, 1, 1, 1, 1, 1. Here we go. So nothing, nothing. 1, 1. 0, 0. Right? You see it? 0, 1, 0. 0, 1, 1. 0, 0, 0. There we go. Ta-da! And that's really this. Now this whole thing being sent in is a tensor because we've just done that same thing with this one, that same thing with this one, that same thing, and so on. Are you following? Does that make sense? Okay, now we know. Now, again, this is labeled data, so we happen to know that's an L, that's an L, not an L, not an L, an L. Even though these are rather primitive, I've kept them down to just 3 blocks. They would be longer, and maybe they started up a little higher in the graphic or a little lower. This will be a little lower, this will be a little higher, and so on. These are clearly not L's. So L, yes, L, yes, L, no, L, no, L, no, and an L, yes. All right, so I've got a 1, 1, 0, 0, 1. Those would be our labels. So we're just going to tack those on to the end. Now we're getting ready to go. So there's my data set. This is just this right here with one thing on the end of it. That's an L. That's an L because that's an L. Are you with me so far? Does that make sense? All right, this is our tensor. That's not an L. The third one is not an L. 1, 2, 3, not an L. 1, 2, 3, not an L, and so on. Okay, these are the features, and that's the label. Okay, good. So far you're with me. Now, by the way, this is a very simplistic version of what neural networks really work with. All right, here we go. Here's the full data set. Here's the label, and here's the features. So I just printed that out. Here's everything. Here's just the features. Here's just the labels. So that's the same thing we just talked about. Okay, good stuff. Now we are ready. We can begin to train the neural network. So we merely set up the neural network and make it equal to what we just created earlier and the X and Y data set. So now we have a neural network with those things. We add in our feed forward, our back propagation, and we say, go for it. So using the numbers in here, our data set, which is this guy right here, and using the neural network, which we created earlier, we add those two things together and it's primed and ready to go. Now we say do the feed forward work and the back propagation work that we defined a little earlier. That's where the sigmoids came into play and the derivative of the sigmoids. And then we say, why don't you go take a peek? And we just did 2 layers because that's what we set up a little earlier. And every one of this, by the way, is called an epoch when you run it. So we run that and it says, okay, good. And it says, hey, just round up the number that's output so that we get a percentage. And here we go. The 2-layer network is 99% sure that 0 is an L, that 1 is an L, that 2 is an L, that 3 is an L, and 4 is an L. And you can see it's pretty sure the first 2 are, it's pretty sure the second and third aren't, and it's pretty sure the third are. Now we can begin to show it data that it has never seen, and it can do predictions because we have trained it. Wow. And then at the very end, I've got a link for you here to define your own neural network from scratch in Python. So now that's deep learning. And again, let me get you to that resource here. Let me pop over to do that. Yeah, here's that link I mentioned a moment ago. Definitely check out this video. The guy's so good at doing this. And it's a fun set of video to watch, but do leave yourself. It's about 3 hours long, so you'll need some time. Let me slide myself out of the way here because I want to move forward into our next where do you do this? How do you do this? What platforms can you use to do this on? Well, you've got several choices. Not only do you have the ability to train and deploy in the cloud. Keep in mind the training is one step and normally needs large machines, but the deployment doesn't, can be on quite small machines. You can do that on the cloud, or you can do it locally on-prem, and there are lots of options that you can go through. Let me slide myself over again here and get myself a little smaller and out of the way. There we go. I look a little better that way. I'm always better when I'm smaller anyway, aren't I? So you've got lots of platforms you can use. Now I've actually got a session here that you can use for this. There are really four that I go over. The first is using the database as a source to pull data in from, and we saw an example of that in the very first example that we talked about. And then that also showed us the call to pre-built AI, and that's another method you can use. And by the way, you can use all these at once. You can use the database as a source to call out to pre-built AI, and you can use cognitive services, or you could use machine learning and sort of build your own. There's also inside SQL Server, you've got multiple locations, a virtual machine, SQL Server itself, big data clusters, managed instance, and even the edge has machine learning services built in, so you can train, experiment, train, you can store your models, and then you can deploy within the database. It can do the scoring as well. It's called batch to do it that way. But then the most complex one and the most common one is the hybrid mode, and we see this sort of come up quite often within the system. So these are the various places that you can install. You've got options is sort of the point. You don't have to be stuck in one area. And again, you can set these up in a hybrid mode, which is what I normally do. I use some pre-built stuff when I can, and I build my own when I can't and go from there. Well, that's the way these work. Make sure you fill out your session evaluation. The feedback that we get is very important for the speakers and for the past community to do better. I just want to thank you for your time today and for listening to this plethora of information. Much more to go through, much more that we need to figure out, especially in the deep learning side. But I hope this has given you a place where you can learn to do predictive analytic workloads inside SQL Server. Listen, I thank you a lot. Let me get myself out of the logo here. There we go. Definitely appreciate your time today, and I hope you're able to use some of these constructs in your day-to-day work. Machine learning, AI, deep learning, fascinating fields. Even if you don't plan to go into them, there's something you should definitely check out. Thanks for watching.